Hello and welcome to Advent of Code in F Sharp day 15. I am very late to the party today because I had an early start for work and I did not have enough time to solve the puzzle. So this won't be a live code, let me figuring out everything, because as you can see, I've already got my 2 stars. But I wanted to upload a quick video where I explain my thinking process and my solution. First things first, there is probably a very clever way to solve today's puzzle within reasonable amount of time. If you're here for that, this is not the channel. I brute forced my way through, and part 2 took a bit longer, but it only took like 1.5 minutes. I consider that reasonably fast enough for me to throw in the hatchet. So this is a brute force approach, disclaimer, and it works something like this. My general idea for my algorithm was to keep track of, the big picture idea is to just generate the sequence of numbers. So if you look at today's puzzle, it's like a game the elves are playing, and each turn one of the elves looks at the number the previous elf shouted, and depending on these rules here, they shout the next number. So this is like an infinite game. They keep playing until they get tired of it, or until, what was it, dinner is served? Yeah, I thought it until dinner was served. Yeah, until dinner is ready. So that's a great stopping condition. So my approach was to generate actually the sequence of numbers, or the sequence of turns, and to just grab the 2020th number out of the sequence we generate. And apparently that works for part 1, and then part 2. The only change is that we're going to look much further down in the sequence, and as I said, I just let it run for a bit longer, which is like 1.5 minutes longer, but it worked, and I'm happy enough with my solution, so let me share it with you now. So the big picture is this thing. We're generating an infinite sequence, and how am I doing this? So this is a function, and it returns a sequence. This is a computation expression that's like used, or that you can use to describe sequences. And within those computation expressions, you can use stuff like yield, return, stuff like that. But how can you read this? Basically, it's saying, okay, if you call this function generate sequence, given an input turn, it will return a sequence of turns. And the implementation is, okay, so we will be building a sequence, and the first thing this sequence will contain is the actual turn we've been given. Oh, this is some debugging information to see how fast my algorithm was converging for part 2. And this statement is saying, okay, so this sequence will contain something else, and it will contain actually whatever this sequence will contain. So this is the recursive call, but instead of just piping in the turn, we calculate the next turn here, and then this is basically an infinite loop and a while true. It keeps like calling itself, returning state, generating next state, and on and on and on. And we use it here, like we find the nth turn, or the nth number, by generating the infinite sequence for till eternity, and we only take the number because there's not only the number in there, there's some bookkeeping, but I'll get over that, or I'll handle that in a second. And we just look for the ask number. I'm doing a bit of magic, like number minus the input length, but that's because of the way the algorithm works, because we are not starting from scratch, we are starting from a given number of inputs. So for example, the example discusses 036, we've been given the first 3 numbers, and that's, so I subtract 3, because I don't have like states in the sequence I generate for the seed values. And then basically this is the next interesting part. So I'm not just generating numbers, I'm doing some bookkeeping. And the bookkeeping I do is I keep track of the current time, because I need that for something later. And then the number that the previous elf shouted is in here as well. And then this is the bookkeeping I'm talking about. For every number that we ever heard, I keep track of like when was the last time, so the last timestamp we heard someone shout this number. And that's it. With this data structure, you can generate the entire sequence. So to generate the entire sequence, you need a starting point, and this function takes the seed. So for example, it takes 036 and it generates like the turn record here with all the stuff initialized. So what is initialized? Timestamp is initialized to 2 in this example because we had 0, 1, 2. The number itself was the last number we get in our seed, so that's 6 in this case. And the lookup table is basically just saying that at time 0 we heard 0, or 0 was heard last at time 0, 3 was heard last at time 1, and 6 was heard last at time 2. That's what is a mapping of the seed to and using an index to tuple of the number and the index. So the index is the timestamp when we heard it, and then just putting this in a lookup table or in a F# map collection. And then the last piece of the puzzle is this next function, which given an input term calculates the turn is the record type we define here. So given the state we use, calculate the next state. And that's pretty straightforward as well. It's just saying, okay, so the next time is just increase it by 1, and then look up the last number we heard, so turn.number, into our lookup table. If we find nothing, so it's a brand new number that only the last elf shouted, then we say 0 because it's the first occurrence, and we add like to the bookkeeping that at turn timestamp. So at the previous turn, the previous number was shouted. So this is for new numbers. And for this was an edge case that took me some while to figure out. But if you see it, the state like this, the 6 is already in a lookup table. I got really confused, but this is basically just there to handle the last value in the seed correctly. And then this is actually the interesting part where we actually heard a number before. So this is the timestamp when we last heard that number. We just calculate the age, or like the difference between now and that last time. And that is the next number we will shout. And we also do the bookkeeping here for the previous elf's number. And that's it. So it's really naive. It's a literal translation of the examples and the rules to an algorithm, to F# code. It works really well for small numbers. It takes a while to calculate the 30th million, or I don't know how big this number was, but I'm happy enough with 1.5 minutes of calculation time. So I will be looking up if there's a quicker way, but I won't be doing this on stream today. So yeah, this is my implementation of day 15 in F#. Hope you had fun, and I'll see you tomorrow.